So for this afternoon, we will officially begin another chapter of topic. Particularly, we will discuss all about isomerism. Okay? Medyo hayag kayo ang ako ang screen because of my lights. Kadot lang ako lang ipa. Kana. Maratag kuhaon sa langit. Sige, kana. So, I repeat, we will discuss all about isomerism. Now, yung isomerism class, that is one of the properties of carbon. Diba? In organic chemistry, our yung main heart, kumbaga, or the main element that we usually tackle kapag org chem is the carbon element. So it is very important that you also be familiar with different properties of carbon itself. Although some of the properties were discussed already in our previous discussion, I will still be introducing few of them. For example, we have stability. So we all know na yung carbon atom as an element, it is considered highly stable. Particularly, yung stability niya, it is relative to what we call octet rule. Diba, pag sinabing octet rule, yung mismong element in a structure must have 8 surrounding valence electrons. Wherein, for carbon atom, in a structure, yung 8 valence electron niya is being shared by 4 covalent bonds. Pwedeng yung carbon in a structure could have 4 single bonds, or pwede din naman ang carbon in a structure would carry 1 double bond, then the other 2 are single bonds, so equivalent pa rin to 4 covalent bonds. Pwede din naman 2 pairs of double bonds. So, 4 din yan. 4 na bond lines, no? Covalent bonds. Or, pwede din ang carbon will carry 1 triple bond. Then, yung isa is a single bond. So, we consider na ang carbon element in any structure is highly stable kasi always it will share its 4 valence electron. Okay? So, to attain its stability, kailangan niyang i-share forming 4 covalent bonds or total of 8 surrounding electrons. Okay? Now, another properties of carbon is hybridization. So, you have already known hybridization, diba? This is the mixing of 2 or more atomic orbitals in order to form a new set of equivalent orbitals. Particularly, yung bagong equivalent orbitals being formed upon mixing, that is already known as hybrid orbitals. So we have different types, diba, ng hybridization. So we have 5 types of hybridization relative to the molecular geometry. Let's say, for instance, kapag linear, merong particular, kapag ang orientation, kumbaga, ng central atom is in a linear orientation, meron siyang specific hybridization. Okay? So for the carbon, a carbon element in a structure, it could exhibit different hybridization as well. Particularly, it can only exhibit three hybridization, knowing na it has 4 surrounding covalent bonds lang naman. So hanggang sp3 lang siya. Okay, kasi yung sp3d, sp3d2, kapag more than 4 na yung bonds, di ba, present in a central atom, tsaka na yung observable na higher level of hybridized central atom. Now, for carbon atom, yun na nga, it can only exhibit sp, sp2, or sp3 hybridization. Now, how do we identify if that carbon element is in sp3 hybridized or hybridization? Naka-sp3 hybridized yung carbon atom in an element if it has 4 single bonds surrounding it. So, ibig sabihin, kung what surrounds a carbon in that structure, puro single bonds, all are single bonds surrounding that central carbon atom, then that is in an sp3 hybridization. Alright? So, kapag naka-sp3, if we try to relate that to its orientation or molecular geometry, we could say na yung carbon atom na yan is in a tetrahedral orientation. Kasi meron siyang apat na electron groups, di ba? 1, 2, 3, 4. So, tetrahedral ito. Okay, tetrahedral. Okay, any central atom na naka-sp3 hybridized, yung orientation yan is in a tetrahedral orientation. Now, ang carbon atom naman, kapag it carries one double bond, I-repeat, kapag meron ng presence of one double bond per carbon atom in a structure, so halimbawa, ito, diba? Each of that carbon atoms, meron silang one double bond, no? That surrounds them. So if that is the case, that carbon atom is in its sp2 hybridized. Okay, sp2 hybridized. So kapag naka-sp2 hybridized naman, if we relate that to its orientation, spatial orientation, it's in its that trigonal planar. 'Di ba? Kapag sp2 trigonal planar. Then kapag naman may presence na ng triple bond, is halimbawa itong dalawang carbon na to, each of that carbon atoms, meron silang surrounding one triple bond. Kapag may one, let's bond ha, one triple bond. Okay, for that particular carbon, then each of that carbon, okay, is in sp hybridized. So yan yung kumbaga hint nyo. Okay, tama. Yan yung hint nyo ha, by just looking at the structure ng hydrocarbons. If you are to identify what is the hybridization of that carbon atom in a structure, you simply look at the surrounding bonds of that carbon. If puro single bonds, sp3. If may presence ng isang double bond in that particular carbon atom, sp2 yan. If meron na siyang triple bond, sp. Another case ng sp hybridized carbon atom is itong nasa gitna, itong boxed with color red. Diba, you will observe nakalinear din siya. At this time, it has surrounding how many double bonds? 2 pairs, no, of double bonds. Okay? Dalawang pairs ng double bond surrounding a carbon atom in a structure, then that is labeled as sp pa rin. sp hybridized. Kasi kapag sp, yun na nga sabi ni Mr. Axial, it's in a linear orientation. Okay, so parehas sila, naka-linear orientation kasi total of 2 electron groups ang being nagsurround, no, for that carbon element. O, let me ask you, itong mga carbon atoms, okay, on the right and left, okay, ano naman yung hybridization nito? If yung nasa gitna sp, you will observe, okay, na yung nasa right and left carbon, they contain one double bond. Di ba? Meron silang tig-iisang double bond. Ito yun. Okay? Meron silang surrounding one double bond. So, pag may presence ng one double bond on that carbon atom, sp2. Okay? sp2 hybridized. Okay? So, kapag sp2 hybridized, trigonal, planar yung orientation niya. Okay? Sige, so these are the first two, no, properties of carbon. And yung isomerism, which will be our topic for this afternoon, this is also a property, one of the properties of carbon, isomerism. So, from the word isomer, diba? Many times na mention Ang isomer na term, kapag isomer, same formula. Same formula, but they differ on the structure. Ayan. So, yan yung tandaan nyo kapag isomer. Kapag isomerism, that is the phenomenon, the existence of two or more molecules having same formula but different structure. Okay, so kapag different na yung structure ng molecule, automatic they are different molecules. Different molecules kasi magkaiba na yung structure nila. Kaya may nakalagay dito, different yung properties ng molecules na yan. Okay? The same lang yung formula nila, yung condensed formula nila, but when you check on its properties, when you try to test for its properties, physical, chemical properties, magkaiba talaga yung ibibigay nila na o ireresulta nila na properties kasi magkaiba na in totality yung molecule. Okay? Now, when we talk about isomerism, diba, it is being highlighted magkaiba yung structures, different yung structure. Now, why is it different yung structure? Different yung structure in terms of, ayan, they may differ. They may differ in the order of bonding. So, ito yun. Ito yung letter A. They may differ in the carbon skeleton. Kumbaga, yung order of bonding sa mismong carbon skeleton. Or, yung differences ng structure could be due to differences ng spatial orientation. Ito naman yun. Ay, sorry. Itong differences in the arrangement of atoms in space. Ito yung letter B. Okay, so parehas lang yan. Kapag yung structure nag-differ due to the differences in the arrangement of atoms in space, ito lang din yun, yung letter B. They differ in the spatial orientation. Kapag they differ in the arrangement of atoms along the carbon skeleton, ito yung letter A. Okay, equivalent lang yan. They differ in the order of bonding. Okay? So, knowing na merong dalawang, kumbaga, conditions ng differences sa structure that could be either differences sa order of bonding or differences in the spatial orientation. With that, we could conclude na merong dalawang types of isomerism. Okay, meron tayong dalawang classifications, kumbaga, ng isomerism. So, una, we have the structural. Sulat nyo, structural or the constitutional. This is also known as constitutional isomerism. The other one is the stereo isomerism. Okay? So class, kapag ang differences sa structure, listen ha, kapag ang differences sa structure ng mga isomers is due to differences in the order of bonding, then that is considered structural isomerism. Kapag naman ang differences sa structure ng molecules is due to differences sa spatial orientation, yung differences nila sa arrangement ng atoms in space sa ilahang 3D, three-dimensional arrangement ng atoms, kung yan, diyan sila nag-differ sa structure, that falls under stereoisomerism. Excuse me. So, yan yung dalawang classifications ng isomerism. Okay? So, in the slide, ito yung magiging diagram flow ng discussion natin all about isomerism. So, I have mentioned, diba kanina, structural and stereoisomerism. Ito yung two general classification of isomerism. Kapag nag-differ in the order of bonding, structural yun. Kapag nag-differ in the spatial orientation, stereoisomerism yun. Now, for this afternoon, we will be discussing all about structural isomerism. Ano yung mga types, specific types of structural isomerism. So, we have 6, particularly yung first 3 dyan. These are the common, no? The common types of structural isomerism. Yung remaining 3 dyan, rarely encountered lang sila. Okay, rarely encountered. Kumbaga, meron tayong distinctions kung saan lang nag-occur yung remaining three. Okay, meron silang particular set of molecules kung saan sila na-encounter. So rarely encountered yung meta, tau-2, at saka ring chain isomerism. The next meeting, we will be discussing the three types of stereoisomerisms: geometric, optical, conformational. Okay, so ito muna yung itatakal natin, all about structural isomerism. So again, I repeat, ang structural isomerism, ang differences sa structure is due to differences in the order of bonding. In order of bonding. So generally speaking, when you will be encountering structures under chain, positional, functional, until ring chain, nagkakaiba yung structures nila based on the order of bonding. Okay, so another thing na dapat nyong i-familiarize, no, for this isomerism topic, familiarize or master the identification of the types of isomerism. Do not worry with the drawing. I will not let you draw the isomer of this formula. What is the isomers that we could obtain with this formula, C4H12? Ayan. You don't have to draw it. For the assessments that involves isomerism, all the structures, the names of the molecules will be given. You just have to identify the type of the isomerism. Okay, so yan lang yung imamaster nyo for this topic. So let's begin with the first type of structural isomerism. So una, we have the chain, no? Chain isomerism. Yung chain isomerism class, ito yung tandaan nyo, this commonly occurs among alkanes. So no problem kapag alkanes kasi you have encountered many alkanes. You have named, no, alkanes structures. So kapag alkanes, yung structural feature na makikita is carbon to carbon single bond or carbon to hydrogen single bond. Now, sorry. Okay, ayan. So for chain isomerism, this is observable among molecules wherein yung carbon atoms are linked to the parent chain or main chain in different ways. Kumbaga, nagkakaroon ng branching. Okay, yung carbon atoms are linked or yung branched are linked in different ways. Nagkakaroon ng mga sanga-sanga yung alkene. So halimbawa, we're talking about alkane, so you have to take note of the general formula ng alkanes. Diba? Ang formula ng alkanes, general formula is CN H2N plus 2. Okay? Now, given this, given that particular, nagloading. Ayan. So, given that formula of an alkane, what do you think would be the one of the straight chain alkane that you could obtain with that formula, C4H10? Apat yung carbon. Okay, butane. Ganun lang, kapag alkane, tingnan mo lang yung number of carbon atoms. Diba? Kapag apat yung carbon, then that is butane. Okay, butane. So one of the molecule that we could obtain from this formula is the normal butane. So kapag N-butane, normal yan, normal butane. Ibig sabihin, yung carbon atoms in that molecule are all connected in a row. Walang sanga. Okay, straight chain lang. Now, I have discussed to you when I introduced alkyl groups na si butane, meron siyang isomer. Ano yung isomer ng butane? It's isomer of butane. So what would be the name? Isobutane. Diba naalala? I have this introduced to you, yung isobutane, and it has this structure. Diba? It has a 3-carbon chain with a branch at carbon 2. Meron siyang methyl at carbon 2. When you compare, let me zoom, ayan, magnify the structure. Now, if you compare the number of carbon atoms, the number of hydrogen atoms in both molecules, they have the same number of carbon atoms and hydrogen atoms. Let's try to check, ha? So, butane has 4 carbon atoms. Isobutane, tingnan yung nasa baba. 1, 2, 3, 4. Okay, meron din siyang 4. In totality, 4 na carbon atoms. What about the hydrogen? For isobutane first. So you have, sa mga terminal carbon atoms, merong tigta-tatlo. So 3, 6, 9, then 10. Okay? Then the same with butane. Butane, yung nasa taas, it also contains 10 number of hydrogen. So you'll observe here na same yung formula nila, but they differ in the structure. Particularly, they differ in the structure because of the branching. Nakuha? Kasi sa isobutane, meron ng branch. No? Meron ng branch. Okay? Present. So, yan yung chain isomerism. Commonly occurs among alkanes because of the possibility of branching. Okay, let's have another example. C5H12. So, this would be pentane. Ayan. Okay, so kapag pentane, 5 carbon, 12 hydrogen. Using this, try to utilize this formula. CnH2n plus 2, kapag 5 yung carbon, then you'll have 12 hydrogens for pentane. Now, for pentane, it has 2 isomers. We could obtain 2 more structures from this formula. Again, we could obtain 2 more. Okay? 2 more structures from C5H12. And that is, ayan, the isopentane. Okay, very good. And the neopentane. Remember, I have given this as one of your assignments. Although, kuan lang siya independent study, part of your independent study sa alkyl groups. I let you search for the structure of neopentane, isopentane. So somehow you get exposed na to this structure. Okay? Now, yung gagawin natin ngayon is to check if neopentane, isopentane will really have this formula. No? Kung meron ba talaga silang 5 carbon, then 12 hydrogen. Kasi no problem with pentane. Pentane will always have C5H12. Now, let's try to check neopentane first. Meron siyang 5 carbon, so C5. Then try to check the surrounding hydrogens. 3, 6, 9, 12. No? So 12. Okay, isomers sila with pentane and neopentane. What about isopentane? So obvious naman yung pangalan itself, isomer daw ng pentane yung isopentane. But let's try to double check, no? Kung C5H12 din yung formula niya. So for its carbon, diba, meron siyang 4 carbon parent chain, then merong branch na methyl. So total of 5. No, 5 carbon. Then the hydrogens 12 din. No, 3, 6, 9, 10, 11, 12. Okay? So the same formula, different yung structure nila. Bakit again different yung structure? Due to branching. May branches na. Neopentane, may branching. Isopentane, ganun din, may branching. Now let me ask you the systematic name of isopentane. You type in your answer. Kapag systematic name, the IUPAC name, meaning following the set of rules na binigay ni IUPAC. Ano yung systematic name of isopentane? This is an alkane with a 4-carbon containing parent chain and merong methyl na substituent at carbon 2. So what would be the name? What would be the name of systematic name of isopentane? It's 2-methyl. Okay, very good. Butane. What about neopentane? Neopentane. Madali lang mag-name kapag alkane. Lalo na kapag maliit na structure ng alkane. This is just an alkane class. Sige, so 3-carbon chain. Okay, very good. So this is 2,2-dimethyl. Ayan, dimethyl propane. Okay, this is carbon 1, 2, 3. So at carbon 2, merong dalawang methyl, kaya 2,2-dimethyl. Okay? Sige. So that is all about chain isomerism. So let's have more examples. So halimbawa, proceed tayo sa hexane. So for hexane, for a while. Ayan. For hexane, 'di ba, 6 carbons 'yan and then 14, tama ba? 14 yung hydrogen, CnH2n plus 2. Okay, tama. Now, let me give only the the skeletal structure para mapadali lang natin yung pag-obtain ng, or pag-draw ng structures. Sige, for hexane, normal hexane, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So that is one structure na pwede nating ma-obtain with this formula. So this is normal hexane. Now we have actually four possible isomers of hexane. Okay, of normal hexane. So pwedeng 1, 2, 3, 4, ayan. 5 carbon containing parent chain. Then yung isang carbon, yung pang-anim na carbon is already a branch. Okay? So pwedeng ilagay natin yung branch sa unang carbon. So if you will try to check the number of carbons here and the number of hydrogens, this will also have the formula C6H14. Okay, so another example, pwede din naman yung 5 carbon containing parent chain, then yung pang-anim na carbon na branch, this time nasa pangatlong carbon. So ito yung pang-anim kumbaga na carbon. So C6H14 din yan, nilipat lang natin yung branching. Okay? Now another isomer na pwede nating ma-obtain, okay, with this formula is let's have a 4-carbon parent chain, 4 carbon containing na parent chain. So 1, 2, 3, 4. So kulang ng dalawa. Kasi C6, 6 dapat yung carbon. So yung dalawang carbon magiging methyl groups, branches na sila. Okay, so you can have one branch here, another branch. So C6H14 din yan. And lastly, pwedeng itong carbon na to, okay, itong methyl groups, they are attached on the same carbon of the main chain or parent chain. So 4 ulit na carbon containing parent chain yung dalawang remaining carbon para maging 6 lahat yung carbon, lagay natin sa same site, no? Same location ng carbon. So lahat yan, ito, they will have C6H14, okay, na formula. Okay, so yan yung all about chain isomerism. Diba? Lahat ng dinro ko, nagkakaiba ngayon yung structures because of the branching. Diba? Yung alkanes, we could obtain isomers because of their possibility of branching. We simply produce branched alkanes, branched chain alkanes. Okay, so yan yung chain isomerism. Nakuha? So dapat inyo lang tandaan, it commonly occurs among alkanes. And another thing, another hint nyo kapag chain isomerism, kapag ang pangalan ng chemical or yung chemical names, no? Chemical names ng alkanes have prefixes like neo, iso, let's have tert also, and ano yung isa? Sec. Diba? You have encountered uh, mga alkanes with this prefixes, sec, tert, iso, neo. Kapag may prefixes, okay, yung chemical names ng alkanes na ganito, they are classified as chain isomerism. For alkanes ha, kapag alkanes with prefixes na neo, iso, tert, sec, they are usually classified as chain isomerism. Okay? Sige, let us proceed to position isomerism. Kapag naman position isomerism class, this occurs because of differences in the position. No? From the name itself, position isomerism. So nagkakaiba yung structure ng molecules because of the differences in the position of functional groups or position of substituents. So yan yung tandaan nyo. Nagkakaiba yung structure ng molecules because different yung positions ng functional groups or position ng substituents. So example, in this given formula, C4H8, sabi dito, ito daw ay isang alkene with one double bond. Now, what do you think would be one of the possible alkene kapag apat yung carbon? Yung straight chain alkene na apat yung carbon. What do you think is that alkene? Apat yung carbon, so you will obtain butene. Diba? Butene. Okay, very good. So one of the molecule that we could obtain from C4H8 is the normal butene, okay, which is, so example would be 1-butene, okay, 1-butene. 1-butene yung being, being presented here. Naka-kekule yung isa, yung nasa baba, skeletal. Formula, but it's just the same, 1-butene yan. Kasi 'di ba, we begin numbering kung saan malapit yung functional group na double bond. So this would be carbon 1, 2, 3, 4. Kaya this is 1-butene. We have to indicate the position of the double bond here. Now, sabi sa position isomerism, ang mga set of molecules nagkakaiba sa structure dahil sa differences ng position of functional groups. So from 1-butene, if we try to transfer the double bond to carbon 2, that will already, you will already obtain a different structure there. No? A different structure. Kasi 2-butene na yan this time. Magkaiba yung 1-butene sa 2-butene. But if you try to check their formula, they will have formula C4H8. Kasi yung nangyari lang para ma-obtain yung 2-butene, you simply transfer the location of the double bond. Wala kang inumit, 'di ba, na hydrogen sa in totality, no, wala kang inumit. Wala kay giumit ba? Giumit nga hydrogen or carbon atoms in the whole molecule. The same lang, nag-transfer ka lang ng position of the double bond. Okay, so this is a good example of position isomerism. Diba? Kung imo siyang i-compare, ang dalawang structure magkaiba dahil different yung positions ng double bond. different yung position ng functional group. Double bond is a functional group, diba, of an alkene. Okay? Sige. Another example, C3H7Br. This is an example of halide. No? Haloalkane or halide. Kumbaga, meron kang alkane chain with a halogen. Now, for this formula, we could have the bromo attached to carbon 1 or a bromo attached to carbon 2. So, example din yan ng position isomerism. Kasi, the structure differs due to differences in the position of bromo. No, nagkaiba lang sila sa positioning ng bromo, but they still have the same formula. Kapag binilang mo yung number of carbon for each structure, 3, binilang mo yung hydrogen atoms, 7, then isang bromo. Let's try to check the number of hydrogens. No? So for each terminal carbon, di ba? Each terminal carbon, since yung being presented lang is isang bond, so meron yang imaginary each na 3 hydrogen. So hydrogen, so 6 na yan. Yung ikapitong hydrogen nandito sa gitna, di ba? So this is also a hydrogen. That's why 7 yung hydrogen. Imaginary nga lang kasi yung structure is in a skeletal structure. Yeah, another example of position isomerism. Now you will observe na lahat ng molecules dito na sa C5H12O, lahat ng molecules being presented, yung 3, merong functional group na alcohol. Diba? Alcohol is OH. Okay? So you have an OH at carbon 1 for the first molecule. Sa second molecule or second structure, ang alcohol is attached at carbon 2. Sa third structure, yung alcohol is attached at carbon 3. Okay? But same number of carbon atoms. 5 yung carbon, 12 yung hydrogen, 1 yung oxygen. Same formula. Different lang yung structure dahil different yung positions ng alcohol. Diba? Yung isa, 1 pentanol or pentanol. Yung pangalawa, 2 pentanol. Yung pangatlo, 3 pentanol. Never mind the namings, no, ng mga compounds na hindi pa natin na-tackle yung nomenclature. Okay, but for some chemical names dyan, like alkenes, diba, yung alkanes, alkynes. Sige. So that's it for position isomerism. Now, another cases wherein we can also encounter positional or position isomerism is among di-substituted benzene rings. Substituted benzene ring. Di-substituted, ibig sabihin, sa isang benzene molecule, merong 2 substituents attached to it. We can also observe position isomerism in that case. Okay? So let's have an example. Halimbawa, ayan. You have a benzene ring with a chloro. Okay? You have a benzene ring with 2 chloro as a substituent. Okay? No, with regards to naming of benzene, diba, in naming any chemical organic compounds, makati yung ilong ko do. Ewan ko. Ayan. Sige. So, with regards to naming ng mga benzene rings, diba, you have to first find the parent chain. Now, any benzene molecules, yung magiging parent automatically is the benzene ring. Kaya sulat nyo agad benzene. Okay? If you are to name a benzene molecule, a substituted, listen ha, if you are to name a substituted benzene ring, automatic yung benzene molecule, itong part na to is already the parent. So no problem, pag encircle nimo sa benzene ring, that is already the parent. Ang inyuha na lang i-identify is the substituent. So no problem with the numbering kasi you have encountered cyclic rings naman. Example, cycloalkanes, cycloalkenes. The same way of how you number substituents sa mga cyclic rings, alphabetical priority pa rin. Okay, but since parehas lang naman yung substituent in this case, so you don't have, ayun na pamili, no? Parehas naman chloro, so pwede ka ni ang number 1, then 2, then rotate. Okay? So, when you identify the substituents, ganun lang din, you use prefixes, multiplier prefixes if dalawa, yung the same substituents are present in there, so dapat imo siyang gamitan og multiplier prefixes. So you have dichloro. Okay, dichloro, one word. Ayan, then you indicate the position of the chloro. Magkatabi, 1, 2, dash. Kaya 1, 2 dichlorobenzene yung nakasulat dyan. Okay, ganun din sa second molecule. Okay, you look for the point of attachment as carbon 1. So parehas lang naman chloro. Pwedeng ito yung carbon 1, ito yung carbon 3. Parehas lang, 1, 3 pa rin yung makukuha mong locations for the substituent. So 1, 3 dichlorobenzene. Then ito din, ito naman 1, 4. Okay, 1, 4 dichlorobenzene. Okay, this is how you name benzene molecules, substituted benzene molecules. Now, going back to the position isomerism, we actually have prefixes, no, that is used to indicate the position of the two substituents attached to benzene rings. I repeat ha, meron tayong ginagamit na mga prefixes to indicate the position of the substituents in a benzene ring, particularly yung dalawang substituents in a benzene ring. So we have what we call, ayan, ortho, meta, and para. Ortho, meta, and para. So ito yung mga prefixes that indicates position of substituents in a di-substituted benzene ring. So, kailan natin gagamitin yung ortho? Ayan. So, yung ortho, it refers to two adjacent positions of substituents on a benzene ring. So, kapag sinabing adjacent, magkatabi. Diba? Magkatabi. So, given this set of di-substituted benzene ring structures, molecule 1, 2, 3, saan natin pwede gamitin yung ortho? 1, 2, 3. Okay, molecule 1, very good. Kasi magkatabi. So instead of 1, 2, listen class, instead of using 1, 2 for the location of the 2 chloro, you can use the prefix ortho. Okay, so magiging ortho dichlorobenzene. Okay, ortho dichlorobenzene. Okay, now, kapag meta naman, this refers to the position separated by one carbon atom on a benzene ring. Ibig sabihin, may one carbon apart, okay, between the two substituents. So obviously, okay, very good. Obviously, it is applicable to structure 2, no, molecule 2. So instead of 1, 3, pwedeng yung gamitin mo na prefix to indicate the position of the chloro is meta. So, meta-dichlorobenzene. Okay? And then yung para naman, it refers to the position of substituents occupying the opposite ends. Ibig sabihin, parallel with each other. So, obviously, yung pangatlong molecule, dito natin maa-apply yung para. prefix. Okay, kaya instead of 1,4 dichlorobenzene, you could also use the prefix para. Okay, to indicate that the chloro substituents are opposite from each other, attached opposite, no, position sa benzene ring. Okay, so that's the use of ortho, meta, and para. But if you use ortho, meta, para, dili pwede inyong i-doble ba na mag-use mo og ortho tapos inyo pag yung dugangan og 1, 2. So mahimo lugar siya ortho then 1, 2. No, that is wrong, no? Definitely wrong gina siya. Either lang. If you use the 1, 2, the number as a location, then that's it. But if you prefer the prefixes, then prefix lang alone. Okay? Specifically, yung first initials ng orthometapara, O, M, at saka P, small letters. Another thing that you have to remember, these are applicables. These are applicable only sa di-substituted benzene. Okay? Kapag 3 na, 4, 5 ang substituents ng benzene ring, you cannot use anymore orthometapara. Okay? So please know the conditions of when to use orthometapara. Kapag di-substituted lang yung benzene. Okay? Di-substituted yung benzene. Another thing pag yun, if you encounter, sorry, ayan, a ring but not a benzene ring, ha? Halimbawa, cycloalkane. Diba? This is a cyclohexane. Then merong substituent. Halimbawa, this is a methyl and this is a chloro. So, di-substituted din siya. But this is not a benzene ring. So, you cannot apply ortho, meta, or para here. No? Talagang sa benzene ring lang siya maa-apply. Okay, what else? Can you apply orthometapara if magkaiba yung substituents? So, halimbawa, ito, this is already a benzene ring with a methyl and a chloro. So, magkaiba. Diba? Magkaiba yung substituent, but di-substituted. Dalawa lang yung substituents. Can you apply the orthometapara here? Yes. No? Pwede din. Okay, so how will you name this? So, you will be using ortho, diba? Kasi magkatabi. Ortho kapag adjacent yung substituents. Then alphabetical order, you cite first the substituent that comes first. Alphabetical priority. So chloro, yung mauuna. Very good. So chloro followed by methyl. Then the parent is benzene. So that is how you name di-substituted benzene ring. Yes, Miss January. Do you have question or natuplukan lang? Sige. So that is how you name di-substituted benzene. Pwede kaayo magamit si orthometapara, biskan, kahit magkaiba yung substituents. Okay, sige. Okay, next. So that's it for position, isomerism. Pwede siyang observable sa mga set of molecules na magkaiba yung positions ng functional groups or magkaiba yung positions ng substituents. Okay. Let's proceed to the third. Third na commonly encountered din na type of structural isomerism. Ayan, we have functional isomerism. So yung functional isomerism, it occurs when compounds have different functional groups. So kumbaga, nagkakaiba yung structures dahil yung set of molecules, magkaiba talaga yung functional group present. Okay, magkaiba yung functional group present. And please take note of this, kapag functional isomerism is being observed, they are usually occurs in pairs. So halimbawa, ang alcohol molecule, it will always have an equivalent isomer in a form of ether. Another example, ang aldehyde molecule, if you obtain an aldehyde molecule from a formula, it will also have an equivalent functional isomer in a form of ketone. And another example, kapag carboxylic acid yung pwede mong ma-obtain from a formula, meron din niyang equivalent functional isomer na esters. That's why, sabi dito, it usually occurs in pairs. So halimbawa, C2H6O. Okay? You could obtain here an alcohol and an ether. Ayan. So, di ba alcohol, merong OH. Ether, R-O-R. Okay, now try to compare the number of carbons, the number of hydrogen for these molecules, ethanol and dimethyl ether. Di ba parehas lang? Dalawa yung carbon, 1, 2, 1, 2. Anim yung hydrogen. Compare mo yung hydrogen sa ethanol and then sa baba na structure sa dimethyl ether, anim din. Then tag-iisa sila ng oxygen. So they have the same formula. Nagkakaiba lang sila sa structure dahil different yung functional group present in their individual structures. So yun yung functional isomerism. Nagkakaiba yung structure dahil different yung mismong functional group present. Okay? Sige. Let's have another example. Ayan, C3H6O. So you could obtain here an aldehyde. So kapag aldehyde, yung pair niya is a ketone. Now, try to check natin kung tatlo ba yung carbon for each structure. So for aldehyde, you have 1, 2, 3. So carbon, tatlo. For ketone, 1, 2, 3. Ayan. So tatlo. Hydrogen, 3 plus 2, 5. Then isa, so 6. Oh, what about the other one? So tatlo dito, tatlo din sa kabilang side, so 6. Then tag-iilan silang oxygen, isa. So same formula. But they have different structure due to differences in the functional group. Okay, then C3H6O2, you could obtain here carboxylic acid, then the other one is an ether. Okay, so diba ito yung carboxylic part. This is the ester. Okay, ester portion. Then try to compare. The number of carbon, hydrogen, and oxygen, parehas sila. Different lang yung structure. So isomers sila, particularly functional isomers. So yan yung tandaan nyo about functional isomerism. They usually occurs in pairs. Alcohol, ether, aldehyde, ketone, carboxylic acid, esters. Okay, and these are other examples, no? C4H8O. You could obtain here, again, alcohol and ether. Then you could also obtain a ketone from C4H8O. So yung concept lang dito, or yung point lang dito is nagkakaiba yung structures, 1, 2, 3. Okay? Nagkakaiba sila ng structures dahil different yung functional group present sa individual structure. Yung isa ketone, alcohol, then may ether. Now the other one, C4H6, you could obtain here an alkyne. Then yung isa, yung kabila, alkene. Diba? Magkaiba yung structure but they will have the same formula, C4H6. Alright? So that is the concept of functional isomerism. Do not be confused with the positional isomerism. Kasi sa position isomerism, halimbawa, you have, ayan, there must be the same functional group. Parehas double bond. Yung isa, 1 butene, yung pangalawa, 2 butene. Ito, you will observe a functional group pero parehas lang naman sila ng functional group. Yung pagkakaiba ng structure nila ay dahil sa position ng functional group. Yung functional group sa unang molecule nasa carbon 1, sa second molecule yung functional group nasa carbon 2. Okay, so do not be confused with the positional isomerism to that of functional isomerism. Pagdating sa functional isomerism, talagang yung mismong set of molecules magkakaiba yung functional groups present. May alcohol, may ether, may ketone. Ayan. But same dapat ha, same dapat yung formula. Same dapat yung formula. Kasi, halimbawa, pina-identify kayo class. Kay basin diritsura mo identify na okay na ay halimbawa dito when you are to identify ba later on basing inyohang buhaton ayan inyo i-conclude diretso halimbawa okay may alcohol ito then this one may ether so automatic functional isomerism yung ilalagay nyo. No, you have to check first if yung dalawang presented molecules in that item same ba yung formula nila? What if yung binigay dito apat na carbon? So C3 din ito. C3 CH2 CH2OH. So dito apat ba? Tatlo. No, tatlo yung carbon dito. Then 9 na yung 9 na ba yung hydrogen or pito? 3, 6, 7, 8 pala. 8 yung hydrogen, isa yung oxygen. So this time, hindi na sila isomer. Okay, with the ayan, second molecule. Kasi magkaiba na yung number ng hydrogen. Yung isa 8, yung isa 6 lang. Okay, so you do not conclude directly or type in diretso the classification or the specific types of isomerism. Dapat i-check niyo muna kung parehas ba yung number ng carbon atoms, hydrogen atoms, or oxygen kung merong oxygen or any other atoms present in that set of molecules. Okay? Sige. Then for the rest, remaining three types of structural isomerism, di ba, I have mentioned na they are rarely encountered. So, ato lang i-identify kung saan sila usually observable. So, kapag metamerism, ito yung tandaan nyo class. Kapag metamerism, they specifically occurs among ethers or sulfides. Sulfides, they're just equivalent to thioethers, di ba? Di ba? Ang ethers, ROR. Ang thioethers or sulfide are SR. So if you have set of ethers, magkaiba yung mga structures ng ethers, but the same number of carbon, the same number of hydrogen, oxygen, metamerism yan. Halimbawa, for this first set of 3 molecules, these are all ethers. Diba? These are all ethers, but you will observe na lahat sila merong 4 na carbon, lahat yan. Lahat yan, 4 yung carbon, tig 10 yung hydrogens nila, then tig-iisa sila ng oxygen. So same sila ng formula, parehas sila ethers, metamerism yan. So yan yung tandaan nyo. Specifically, distinct sa kanya na among ethers molecules, metamerism. Or pwede din among sulfides or thioethers. Ayan. So you have set of sulfides, set of thioethers rather, thioethers, then same yung formula nila, then metamerism yan. Okay, so yan yung tandaan nyo, ethers, thioethers, metamerism. Kapag naman tautomerism, ayan, it commonly occurs between a ketone, yan yung tandaan nyo, so ketone, di ba, it's R, C double bond O, then an R group. So kapag ang ketone rather, ang ketone, it freely converts to its enol equivalent. Kapag sinabing enol, combination yan ng alcohol, di ba? OH, alcohol. Kapag double bond, ano yung functional group na yan? It's, okay, alkene. Kaya nga, enol. Okay, so yan yung tandaan nyo kapag tautomerism. If you are being presented with a ketone molecule and yung isa enol, merong double bond tsaka alcohol, then most probably those molecules are tautomers with each other. With regards to the interconversion of a ketone form to enol form or vice versa, enol form to keto form, we will discuss that sa reactions ng mga alkenes. Madadiscuss natin yan sa reactions ng alkenes and reactions ng ketone. So for now, just know na ang tautomerism occurs between ketone and enol structure. Yan muna yung tandaan nyo. Utang ko muna yung mechanism of reactions. Paano yung conversion ng keto to enol. Okay, that's not part of the scope ng isomerism. Okay, sa atin lang is identification muna ng type of isomerism. Okay, then last. Ayan, last one, ring chain isomerism. Okay, from the name itself, ring. So you have a cyclic ring, then a chain isomerism. So ibig sabihin, sa set of molecules, you have an open chain and you have a ring structure, then dapat same sila ng formula. That is considered ring chain isomerism. You have an open chain and a cyclic molecule. Ring chain isomerism. Yan. So a good example is alkene. Pairing that with cycloalkanes. Naalala, if you try to scan over your notes, try to check the general formula of alkenes and also cycloalkanes class. Parehas sila CnH2n. Yan yung formula nila. Meaning same sila ng formula, same sila ng general formula, but you all know na magkaiba naman yung structure, 'di ba, ng alkenes. Magkaiba 'yan sa cycloalkanes. Ang alkenes, open chain, may double bond. Cycloalkanes, it is a cyclic ring, walang double bonds. But they have the same number of carbon, the same number of hydrogen. Okay, so isomers sila. Isomers sila. Ring chain isomerism yan. Another example, alkynes, pairing that to cycloalkenes. Pairing that to cycloalkenes. So they are isomers as well because they have the same general formula, Cn, H2n minus 2. Yan po yung general formula ng alkynes at saka cycloalkene. So let's have a specific example, C3H6. So you could obtain here an alkene, which is a propene. Ayan, di ba? That is propene or 1-propene. What is the equivalent cycloalkene ng propene? Ano ang pangalan ng cycloalkane kapag tatlo yung carbon? Cycloalkane, tatlo yung carbon present in a ring. Okay, very good. Cyclopropane. You just have to convert its equivalent cycloalkane. So tatlong membered, 3 carbon membered rings sa cycloalkane is cyclopropane. Diba? Kung i-check niyo yung number of carbon atoms, ayan, number of carbons for propene, 3. Ilan yung hydrogen? 3 plus 2, then 1, 6. What about cyclopropane? Cyclopropane, obviously, meron siyang 3 corners. So, 3 yung carbon. What about the hydrogen? 2, 2, 4, 6. So, C3H6, same formula sila. But try to look at the arrangement of their atoms. Ang isa cyclic, ang isa open chain, may double bond. So, different structure. Ring chain isomerism yan. Okay, let's have another example. Ayan. So, we have C6H12. So, you could obtain their hexene. So, the equivalent cycloalkane of hexene. Kasi, ang ka-isomer ni alkene class, ang ka-isomer ni alkene is cycloalkane. So, you obtain its equivalent cycloalkane. So, 6 na 6-membered ring for cycloalkane. So, cyclohexane. Okay, very good. Okay, cyclohexane. Oh, what about C5H8? So, you could obtain here an alkyne. Okay, particularly a pentyne. So what would be the equivalent cycloalkene of pentyne? So limang carbon present in a cycloalkene, that would be very good, pentene. Okay, so that's it. So that is how you identify the specific types of structural isomerism. Do you have any question? Sige nga, kung walang question, let's try to identify the answers for this structural isomerisms or molecules being presented. Identify the type of structural isomerism. Give the molecular formula. Kapag sinabing give the molecular formula, simply count. No, simply count the number of carbon atoms or whatever atoms being observed sa both molecules. So you could start with the molecular formula para automatic imuhang ma-check kung parehas ba yung number of carbon atoms, parehas ba yung number of hydrogen atoms. Okay? Sige, you tell me how many carbon atoms both structure. 1, 2, 3, 4, 5, 6. Okay. 6. Then the hydrogen, 3, 6, 9, 12, 13, 14. So isomers sila, 3, 6, 9, 12. Okay. So isomers sila kasi parehas sila. May 6 na carbon, may 14 na hydrogen. Now you tell me, what is the type of isomerism? Sige, class. Nalimtan na namo, ma'am. Okay, very good. It's a chain isomer. No, they are chain isomers. Isomers sila with each other. So chain, kasi both are alkanes. No, both are alkanes. So nagkakaiba lang sila dahil sa branching. No, nilipat lang yung branching. Sige. Number 2, molecular formula muna. So C3. Tama ba? Ilan yung hydrogen? 2, 4, 6. So 6. Pareha sila. 6, hydrogen, 3 carbon. Then, okay, very good. 2, oxygen. So isomers sila with each other, then go identify the type of structural isomerism. What is the type of structural isomerism? Yung isa, carboxylic acid. Yung isa, carboxylic acid. This is carboxylic acid. The other one is, this is an ester, di ba? This is an ester. Okay, very good. This is functional. Functional isomers. Tingnan yung, kumbaga, parang distinction, differences ng dalawang structure. Okay, next. Number 3. Parehas sila. 3 carbon, hydrogen. 3, 6, 7. No? Parehas sila. 7, hydrogen. Chlorine, tigi-isa. Now, you identify. So, isomer sila, and that's the time you could identify now the structural isomerism. Saan sila nagkakaiba? Nagkakaiba sila sa posisyon ni chloro. Okay, very good. So, position. Positional or position. Position, isomer sila. Okay, number 4. Ayan. Try to check muna the molecular formula. 3 yung carbon, 3 each, no? 3 each yung carbon, then hydrogen, 6. Tama ba? 6. Wait. 6 ba? Okay, 6, then isang oxygen. Okay, very good. So yung isa is a ketone. This is a ketone, di ba? R, C double bond O, then R. The other one, merong double bond. Merong alcohol group. What is that? A ketone, yung isa, then isa, enol. Yung una, ketone, yung isa, enol. Are you sure it's functional? Okay, very good. It's tautomerism. Okay, tautomers sila with each other. Tautomerism. Okay? Actually, it is also considered, kung wala sa choices, kung sa choices walang tautomerism, the the best choice here is functional. If walang tautomerism, but if you find out na sa choices merong tautomerism, then that is the best answer. Okay? Kasi it will still fall down no sa functional isomerism. Same formula, different yung structure kasi magkaiba yung functional group. But again ha, if you are to specify talaga, specify the type, particular type, kung saan being observed kapag keto to enol, enol to keto form, that's tautomerism. Okay? Sige. Any questions regarding structural isomerism, class? Okay, none so far. Sige. Since walang tanong, sure ha, walang tanong, I will dismiss you early. Okay? I will now dismiss you. Thank you so much for joining early sa ato ang session. Next meeting ulit. And I'll try my best to meet you kahit sobrang busy. BC. Sige. So thank you everyone. God bless. Thank you for listening for this afternoon. Salamat.
Thank you, ma'am. Goodbye.
Okay, goodbye. Thank you, thank you.
Thank you, ma'am.
Sige, thank you everyone. And you're welcome. Sige, bye-bye.